Hello, this is Minky for the course Probability and Stochastic Process homework for exercise 1. So for this question, we are going to find and draw the distribution function of random variable y and its probability density function. So we are given y equal to gx. We are given this, and based on this piecewise function, we could draw this figure of gx. Let me change the color here. And so we can now discuss y and to get what we want here. So the first situation is y equals to -1, and here the distribution function of y equals to probability that y equals to -1, and if y equals to -1 is here, right? This right line here. So that is x is larger than 2, and based on the definition we could write that this is equals to 1 minus the distribution function of x equals to 2. Yeah, so this is for y equals to -1, and let me get rid of this. And for the second situation is y equals to 0. Y equals to 0 is here, right? So that is x is between 0 and 1, and that is fx1 minus fx0, and when y equals to 2, that is this line. So that is x is smaller than 0. So based on the definition, we could simply write that this is equals to fx0. So for the y is between -1, y is between -1 and 0. That is here. It's much more complicated than the previous situations. So when y is between here, we could solve that the root of x is equals to 1 minus y, and we use the formula. We could calculate the distribution function, the density function of y here. So that is equals to fx 1 minus y here. And based on that, we calculate root is equals to 1 minus y, and we replace x here. So x, we could express the distribution function of y by the probability that x is larger or equal than 1 minus y. So based on the definition, it is 1 minus fx 1 minus y. And we have a definition here is that the density function of x is equals to the sum of the probability times the x minus xy. Right, here is our definition, and we already get the probability that is the distribution function here, all this value. So we could just times the every points the delta function, so we could get the density function of y here. So for y equals to -1, here we can see we just times the delta function, that is when y is equals to -1, so we get the density function of y at this point. Similarly, we could get the density function's value of y equals to 0 and 2, and times the related delta function here. And for y is between -1 and 0, we could just simply write fx1 minus y. So based on the piecewise functions expression, we could draw the figure of density function of y here. Yeah, that is really simple, and I don't have any other things to say. So for the distribution function, we can use integral to get the distribution function from the density function here. So when y is smaller than -1, that is 0, right? And for y is between -1 and 0, we could use integral. So we could get sorry, not integral. We already calculate the distribution function here when y is between -1 and 0. So that is 1 minus capital Fx1 minus y here. And when y is larger than 2, that is 1. So we could use the 1 here to minus fx0. So y is fx0 here. That is, here we can see when y is equals to 2, the density function of that is 2, right? So when we implement the integral from density function to distribution function, there is a leap at the point y equals to 2. So when y is between 0 and 2, that should be 1 minus fx0, and at the point when y equals to 2, there is a leap from the 1 minus fx0 to 1, right? So that is the distribution function of y. Thank you.